Hey everyone, and welcome back to the SaaS developer community. Last week we talked about control planes and we talked about them in depth. We went from requirements to architecture, implementation challenges, and this sparked a lot of debate and feedback both in YouTube, on the chat during the live premiere, on Twitter, on the Slack community. People DM'd us, people called us. It was definitely an exciting topic, which makes sense. When we started the conversation, we asserted that if you are doing infrastructure SaaS, you absolutely have to have the control plane, data plane separation in your architecture. That this is really key for your success. Pretty much everyone agreed with us on this basic, but because it is so critical to the architecture of a lot of SaaS companies, there are a lot of disagreements, point of views, opinions, and debate about everyone else. So I collected the best feedback that we got, and I'm basically just going to go through this with you, make some very light comments, put things in context. The goal here is to share all the viewpoints. Like, just because I'm highlighting something here doesn't mean that I agree, it doesn't mean that I disagree. The goal is to share ideas and learn from each other. And as a reminder, I am still obsessed with control planes, and I'm obsessed with the general patterns around control planes and what people are solving with them, what people are doing, how they're doing things. And I'm obsessed with the idea that we can build platforms and libraries that will encapsulate those patterns and make it so much easier to build control planes. So if you have a control plane, if you are thinking about building one, if you have opinions on how to build one, if you have opinions on whether everyone needs them or some cases, just contact me, let's chat. This topic is just super important and fascinating. So when we first shipped the control plane video, we did it as an instant premiere, which meant that me and Ram were live on YouTube chat and we discussed what was going on in the video with our viewers. And the most active person in that chat was a techie sot. He also goes by, I believe, Lalit. And basically, a techie sot kept just throwing out more challenges that we haven't really went through in depth in the video. And I'm just posting all those challenges here. As you can see, there is just a lot of, even though we talked about a lot of problems, it turns out that there is a lot of other ones. How to manage life cycle of a tenant in a case where they have many different products and many different workloads. What if it's multi-regional architecture? The complexity growing exponentially because you have all those different things interacting with each other. How do you protect the agent? Is the agent just a proxy for the control plane? This is something I will touch on again because I think this is one of the big open architecture questions. Thinking about a management plane, maybe you need a management plane and a control plane. I'm going to talk about this idea a bit more because it also kept coming up. Tenants talking to each other. This is a business requirement that is hard. I've seen SaaS companies do it. I think Snowflake is kind of famous for it, and balancing the need of tenants to share data and the need for isolation is such a challenging one. He said that we didn't touch enough about networking and security. He's right. Those are two huge themes. Maybe one day he will come on the show and we'll talk just about those. Network partitioning and what happens when there's a network partition between the data plane and the control plane. He mentioned observability as being a key requirement, but there's a lot more. We're going to mention that. So thank you, TechieSot, for being in the instant premiere chat and just bringing up so many good points that no matter how complex we thought the control plane is, we missed a bunch of them. And then slightly later, Tom showed up on Twitter and said, what do we even mean by infrastructure as software as a service? And that's a good point. We used this term. We said every infrastructure SaaS requires a control plane. We didn't say what they are. So the way we see it is that there's a lot of SaaS that is just an application. Think about Workday as an example. It manages HR, expense report apps, all those kind of business apps as service are what we call application SaaS. And then below that, you have SaaS that is used to build those. So a lot of database as a service. Snowflake is a great example. Monitoring as a service, like Datadog. Streaming as a service, obviously. Confluent, and there is a bunch of others. All those data building blocks, the ones that they don't just sell disks, like they're one level above infrastructure as a service. It's so they don't sell disks and networks and like CPUs. They sell compute heavy services like machine learning, but it's not an application you can just use as a consumer. You use this to build other things on top. So the canonical examples of infrastructure as software as a service would be Snowflake, MongoDB Atlas, Confluent Cloud, things from cloud providers. So you can imagine Kinesis. I heard Kong, for example, has Proxy as a service. All those infrastructure building blocks that you need to create applications, and you don't want to own yourself. You don't want to own the database yourself or own events or own monitoring. You get these bits of infrastructure as services. So I hope this helps clarify the context for everyone. And thanks, Tom, for asking the hard questions. So one thing that we didn't explicitly say in the architecture video, but just was a common theme across all those conversations, is that there is really three broad infrastructure SaaS architectures. If you think about, and this I'm talking about it in terms of where does the data plane live. You basically have three options on what you do with your data plane if you are infrastructure as a service. You can have multi-tenant data plane. So there will be a lot of tenants sharing the same data plane. And then there is the approach that some customers, or maybe all your customers, will want dedicated resources and isolation. So it's both about security, like they want to know that they have their data and nobody else can touch it. And it's also about performance. They want dedicated compute. It gives them a very stable performance that only they control, no concerns about noisy neighbors. Same for dedicated disks that they get the network. So it makes a lot of sense. But in those cases, in many cases, it's still acceptable to run this dedicated and isolated data plane in the vendor account. And you do things like VPC peering and private link to make sure that you have the network security in place, and you get your machines, you can encrypt the data, you can bring some keys to encrypt this data. But the key thing is that the vendor still runs the machines, it's still in their account, they're still 100% responsible for whatever infrastructure is there completely being up. And then in the third one, the data plane is in the customer account. So the vendor is still responsible for it being up, but the customer has tons of visibility. It sees all the machines, it has root in this account, so it could delete machines if it wanted. We just asked them nicely not to. But the entire data plane is completely owned by the customer. If they want to cut off the vendor, they can do it in an instant. They own all the data. They control every single permission that the vendor gets. And there is some kind of a protocol between what the vendor has on their side and what the customer has on their side that allows some kind of an interaction from a centralized location with the data plane on the customer account. And there are several variations on that as well. And it's interesting because everyone is you'll see in the comments, everyone is very opinionated which model they chose and they're going to go with. But everyone is also aware that just because they went with one model doesn't mean that they will stay forever in that model. So here are some ideas that I think pretty much everyone agreed on. So basically, Swix kind of said that there were a lot of vocal disagreements, and he quoted Brian Offutt, who I believe is an investor with Index Ventures. And Brian Offutt is very much a supporter of the models that Confluent and Mongo and Snowflake and Elastic and a lot of other companies went with, which is that everything runs on the vendor account. It can be dedicated and isolated, it can be multi-tenant, cheap and efficient, but it's all in the vendor account, and Databricks is the one exception. And I think he is right about it, but as you'll see, Databricks is not the one exception. There is more exceptions, and I think the number of exceptions is actually growing quite fast. But here's the thing. Databricks had the deploy in your own cloud model. Confluent had the opposite model. Everything was in Confluent account. And if you compare the architectures, and both companies made them public in various papers and various presentations, you'll see that the architectures look almost exactly the same. There is the control plane, and there is an agent on every data plane, and customers interact with the control plane, and then things get pushed down and executed on the data plane. And we know from Confluent that it would be really easy to deploy this exactly the same, use the exact same architecture to actually run in a customer account. There were business reasons not to do it, not really technical reasons. I bet that the same thing is true from Databricks' point of view. So the architecture patterns are very similar, which means it's great news because you can build a system that will start on one end of the spectrum, whichever one you want as a business, and be flexible enough to move to other models the moment you need it to. So that's fantastic. And Brian Offutt himself clarified he's very much for the architectural pattern of separating data and control plane. No matter what the deployment model you're going to need it, the only question is if the data plane should live in the customer account. And as we'll see later, there is another question, which is where does the control plane live? So Joydeep, who was a founder of Quobble, if I remember correctly, which was an early Hadoop as a service company, he shared a concern about the fragility of a specific architectural pattern. He said, if the data plane depends on the control plane for its availability or for some critical operation, then this is too fragile, because then the control plane becomes a single point of failure for all the data planes, and this is obviously kind of a catastrophe. And I agree with that. Like when you go and design a control plane, data plane architecture, a key requirement that our video did not touch on is that the data plane has to keep working no matter what happens in the control plane. So if you remember, the control plane is where you add users, add organizations, you configure access permissions, for example, you configure a bunch of settings for the data plane. So if it goes down, it is expected that you will not be able to do control plane operations. Maybe you cannot add new users, maybe you cannot change configuration. But the configuration in the data plane as is absolutely has to keep on working. You cannot have a case where the data plane fails because of the control plane. And this is really important to continuously test for, from the basic integration tests to the most extreme chaos engineering. You absolutely have to make sure that those are maybe not completely decoupled, but decoupled enough that if the control plane is down, only control plane operations are affected. the normal use case of your data plane, the queries, the machine learning, the data ingest, the ETL jobs, all those have to keep on running. Kishore from Starter Data, CEO and founder of Starter Data, and also founder of the Apache Pinot project, shared that Starter Data separated data plane, which is presumably Pinot, and the control plane, which is presumably what Starter Data are working on when they're not doing Pinot. He said that while they separated the whole thing, the data plane has a mini control plane as a Kubernetes operator, so you can actually do things on the data plane independently from the control plane, which is 100% the right pattern. We see it all over the place. I love the name of mini control plane as opposed to the agent, and you'll see several other names for that, but mini control plane is a great name. And this mini control plane controls things locally, and I think there's wide agreement that yes, you will need it. So now that we covered the points that everyone agreed on, let's go to the open questions. What are the things that we actually disagreed on? So I think the big thing was, would the control plane actually live in the customer account? You can imagine a world in which the mini control plane is not so mini. It's actually a full-fledged control plane living in the customer account, having whatever access permissions the customer chooses to give it. And the customer has a complete deployment, control plane and data plane. And then the vendor maybe has like a very thin layer that allows users to log in and then immediately redirects everything that they do into the control plane that they own in their account. Or maybe even not that, maybe they really do everything in their own account, but then it kind of raises the question, what does the vendor do? And maybe the only thing you do in this vendor control plane is push out new releases of a control plane and data plane to the customer account and do billing. Maybe that's enough. So definitely an option that exists. I know one or two companies that do it. And it is a good question. Why wouldn't you want that? And the argument for this is to say, okay, just have everything on the customer side. You'll have control plane, you'll have data plane, you'll be completely decoupled from a vendor, and you'll sleep better at night. And I think I completely agree with Jurdeep that the goal of every customer is to have a highly usable system and also to sleep better at night. And I can take those same goals and say the opposite argument. You want a very minimal control plane, and because as we discussed, control plane is actually fairly complex. It does a lot of things and it can be a fairly massive system. So actually have a mini control plane and leave the big control plane to the vendor where he's paid to own all the headaches that come with a system that is not 100% trivial. And this is the way you'll sleep better at night. So, and I think a lot of it really comes down to how complex the control plane really is and how much it does. Whether you manage to do the key goal, one of the key goals of the architecture, which is if the data plane can keep running even when the control plane is down, it almost doesn't matter who owns it, if it's the vendor or the customer, because you'll still sleep well at night, because it's not a big deal if the control plane crashed. The data plane is where most of the business critical things live. So if you manage to decouple the architecture, you'll sleep well at night no matter what. There is some latency concerns. If the control plane is doing something that is kind of latency sensitive, you may have locations that are better for it and you care about that. And then there is a bit of a control-free concern. I think some customers just sleep better when they control everything, and some customers sleep better when they actually can offload a lot of the concerns to a vendor. And it's almost a personality type. And it's kind of interesting. I'll show you later. It kind of went into okay, we're now in this situation where some people are that way, some people the other way. Is it converging in a specific direction? And this is basically kind of a summary, right? The whole thing about who should own what is because we're in a messy middle of cloud adoption. 7 years ago, everything was on-prem. 7 years from now, Brian thinks maybe nothing will be on-prem, nothing will be on the customer side, the vendor will own everything and still have the control plane, data plane separation for all the reasons we discussed, but there will not be the question of the customer running the control plane. We're now in a weird middle. Of course, there is also the opposite. Maybe 7 years from now, it will actually be completely the norm that the customer owns everything and the vendor just pushes out updates because the security scenario and concerns will go in one direction versus the other. Now, the other open question is really around what should the agent architecture be and what should the agent do. So I kind of wrote a small kind of mock example, and in my case, because I'm from the event processing world and from Kafka world, the agent basically pulls the control plane for events. So you imagine the control plane kind of has a Kafka, and the agent will keep saying, hey, is there anything new? And then if it sees a message that says create a new cluster, it goes and creates a new cluster. But there is a good argument, and a bunch of people do it. There's Joydeep, there is a techie thought, there's also friends that I talk to offline. It's fairly popular that the agent is actually a web service, and it acts as a proxy for requests coming from the control plane, and it validates them, it may filter some of them, it checks that the control plane is not exceeding the permissions that it has, that it actually sends relevant data, and then it passes those requests along to the data plane. And this allows for some nice things. And generally speaking, it could be lower latency, you could have more immediate visibility. It's kind of like the old request response model versus event model. Request response is slightly easier to implement. It's very fast and very responsive day to day. But in cases where you have spike in traffic, it's actually very hard to manage. Or if the agent goes down for a bit, what do you do with all the requests that you want to send it? Versus if the agent pulls, then it obviously is in control and it reads stuff whenever it's up. And if it crashes, it comes up and then it reads everything that it missed. And Techisot had a great question, which is how to protect the agent, because if the agent just gets stuff pushed at it, you suddenly start to have the problems of rate limiting, back pressure, and then what does the control plane does when the agent is applying back pressure. It can get pretty complicated, which is why we really like the event model, to be honest, although, as I said, proxies are fairly popular. And proxy is actually useful if you want to really give a centralized experience for your customers. So one thing I've seen from the Snowflake world is that when I configure my SQL client, like in my application, I actually don't need to give him the address of my database. I give him a very general Snowflake address. And I think Snowflake behind the scenes my client connects to the Snowflake control plane and it identifies, and then the Snowflake control plane gives it the IP or address of the data plane service to talk to. And the agent, their client and server do it behind my back. So the user experience is actually really nice. And obviously this is not exactly a proxy, this is more of a router, but proxy would do the same thing, right? Just maybe with a bit higher latency. But it would basically just send the traffic over to the right data plane and send it back. I really like those things in terms of user experience. Hopefully it does. Okay, so we covered two disagreements. One is about how much does the customer own, and the second about proxy versus event polar. And I think the summary was, well, we had several summaries. I really liked the quote from Sepp, which says, "Control pain is the bane of my life." I absolutely love the term control pain. Control pain sometimes does turn into a control pain. We saw from a techie thought how many different problems can happen and how many different things you have to solve. This comment about control pain also reminded me of another pain point that we haven't really touched on until now, which is a lot of time the control plane is owned by one team in your company, and it can be a small team. That's very painful. It can be even a large team, and you can still have the problem because every single feature that you want to ship on the data plane will probably require a new configuration in the control plane to expose this feature to the customer. It has to kind of merge into the control plane user experience because the control plane owns a lot of the user experience by definition. It owns the configuration, so any configuration regarding a new feature has to be exposed there. Again, you don't want a full dependency. You want the data plane to operate independently, but you want to allow to configure those things from the control plane, which means that the team can easily become a bottleneck. So that's another thing you really need to address in your control plane architecture. How do you give data plane teams autonomy to expose new features and new configurations on the control plane without being blocked by the availability of the control plane teams? Even reviews can be sometimes hard to get with a very busy team, so you really need to make it extremely safe and extremely easy for data plane teams to add new configurations. Brian Foot finished on an optimistic side. He said that no matter what the choice of architecture you have, the technology is improving, so things are only getting easier and better. Obviously, I want to contribute to things becoming easier and better, no matter what is the architecture model you go with. And he is 100% right that there is no 100% clear right answer. There is a lot of benefits to owning as much as possible on the vendor side. There's a lot of benefits to having more on the customer side. Realistically, either approach will probably end up in a fairly good business, but, and he's 100% right about that, it changes how you think about the go-to-market. And Ram, which we all know and like a lot, summarized it very similarly. There's a lot of issues around networking, a lot of issues around cost, a lot of issues around trust. All of those can prevent customers from having the data plane on the vendor side, and having to support both customer VPC and hosted VPC is a bad model, but not because it's technically a bad model. You actually want the technologies that can support both, but they're just very different business models, and it can be hard on the GTM and the technology side to try to approach both of those. We're basically wrapping things up here, but I want to mention the idea of trust that Rams brought up and was kind of an ongoing thread in all the conversations, because the customer would give you the control plane if they trusted you. They would give you the data plane if they trusted you. How much of the control plane and the data planes they want to own is probably driven by how much they trust. And something that I always believed on the personal level is that trust is a bit of a competitive advantage. If you trust people, you're open to them, very often everything is lower overhead. You can have simpler conversations, they need to explain less, you have to explain less, you have better relationships, you can help each other more. This is kind of I'm a high trust person. I tend to trust people before I know them and only stop trusting them after they did something to break this trust. And this is kind of part of my personal values. But I also think that as a business, if you are more trusting of your vendors, it means that you have to do less yourself. And obviously, if a vendor breaks your trust, it's a big problem. And obviously, it's not just trust blindly. It's definitely trust by verify, trust by have contractual protections in place, all those things. But by being able to trust, vendors like AWS, Snowflake, Confluent, you do gain the ability of moving faster with lower overhead as a business. And this is a huge competitive advantage, especially for startups. So with that, I'll wish everyone a great weekend and see you all next week. Don't forget, if this topic is interesting, if you have opinions, ping me. I want to hear from you.